Okay folks, today looking at Saddle Up, a Python exercise done in Codewars. And my name is Dean if you don't know. Of course my name is on the page, or the YouTube channel, that's the correct term. So you'll see my name still. Maybe I don't need to say it. But anyway, here we got Saddle Up, a 7 Caillou exercise, Codewars, Python once again. This is a pretty damn good exercise, so let's dive into the joint. Find all the saddle points of a non-empty matrix of integers. When you see a matrix, it's going to be a two-dimensional list, a list of lists really. A saddle point is an element that is minimal in its row and it is maximal in its column. Interesting idea there. Return them in a list of row column coordinates, and the order of the saddle points in the list is irrelevant. To really get what a saddle point is, you got to look at an example. It's not going to be, at least to me, it was not clear initially what the hell dude was talking about. So a saddle point it's an element of a matrix or a two-dimensional list that is it's minimal, or it's the minimum of its row and it is the maximum in its column. Looking at this example right here, the saddle point is a minimum in its row, so you got to get all the minimums of each row. So row 0, the minimum value is 3. Row 1, the minimum value is 0. Next row, minimum value is 2. And the next row, the minimum value is really both of these 3s. So these are all the minimums of each row. And then look column-wise, up and down, to see what are the maximum values in each column. So if you look at column 0 here, the maximum value is a 7. This column, and this is getting kind of messy, the maximum value is a 4. And in this column, the last column, which would be column 2, 0, 1, 2, maximum value is the 3s. So really what we're left with is like what values are a minimum in the row, maximum in their column, and it would be the 3s, because you look at the first row. I think I'll just clear this out a little bit. You look at this first row, a 3 is a minimum, and then you look in this 3's, the column that it's in, and it's the highest because you have a 2 and a 3, so the 3 is the highest here. And this would be a saddle point. And so that saddle point would be 0, 2. Row 0, column 2. Again, the 3 is the max in column 0. Oh, sorry. The 3 is a max in row 0. I said it wrong. The 3 is a minimum in row 0. And it is a maximum in column 2. And then you go down here, this other 3 would be 1 as well, the 3 at the bottom, because in its row, it is a minimum. You see 5, 3, 3, 3 is a minimum. And in its column, it is a maximum. So the other one would be 3, and this would be row 3, 0, 1, 2, 3, column 2. Those are your two saddle points. And just to kind of throw this out there, the other 3s would not be saddle points, because this 3 right here, it's not a minimum in its row. 2 is, and it disqualifies it right off the bat. The next 3 down here, this one, if you look at this one, it is a minimum in its row, but it is not a maximum in its column because you have that 4. So the 2 3s over here are the only saddle points. Kind of a complex idea, but it's a good little brain teaser here. And going down here, you see confirmation that the row minimums are, and it lists all the row minimums. The ones that I just showed you, all the row minimums are 3023. And then the column maximums, 743, 743. Those are your column maximums. And so the 3s in the third column are saddle points, but the 3s in the second column are not. So now when you get the saddle points, what do you do with them? In Python, you return them as a list of tuples. That's how you do it. And I think that's a mistake right there. But you return them as a list of tuples. So each saddle point will be a tuple. 0, 2, put it in a tuple. 3, 2, put it in a tuple. And those two tuples would be in a list. Those are saddle points. And really, the algorithm here is to get all your row minimums, get all your row maximums, get all your row minimums, get all your column maximums, and then you loop through the row minimums, and for each row minimum, try to match it up with a row or a column maximum, and there's your saddle point. I'm getting confused in my explanation, but you'll see it clearer as we dive into the code. Because the code don't lie, my friends. It'll be there plain in black and white, so to speak, even though it's colored here in this situation. All right. So with this code, matrix is going to be a two-dimensional list. And how I decided to approach this this exercise is to use really array manipulation functions or array manipulation stuff from Numpy. Numpy is better at dealing with matrices than regular vanilla Python lists are, so it's going to be easier. So I'm using Numpy in my solution. And you'll see how beneficial it is because I'm going to do slicing to get rows and columns, slicing that you cannot do with regular Python lists, made much easier in Numpy. So you'll see the benefit here pretty soon. The first thing I'm going to do is I'm going to convert my two-dimensional list to a Numpy two-dimensional array by simply using the array function matrix. Yes. So now it's converted to a Numpy two-dimensional array, and then I can move forward with my manipulation. I'm going to get the row minimums. I'm going to get all of them and put them into an array. I think. No, actually I'm putting them into a list using list comprehension. Let's take a look at this this code here. I'm using list comprehension here to get a list of the row minimums. In this latter part of the syntax, I am looping through the matrix array one row at a time, and I'm using the min function and getting a slice of the current row. Now this slice notation is really why I'm using Numpy, because you can't do this with regular Python lists. With Numpy, I can slice into a two-dimensional array to get rows and columns. Here I'm getting a row where I'm doing a slice where I'm isolating on row I and getting everything in that column. I'm isolating on row I and getting all columns in row I, essentially the entire row. When you do the colon only syntax, you probably know this from regular Python slicing, that colon syntax means everything in the set of what you're slicing. So this is going to give me everything in the row. So it's row I and then everything in that row, meaning all columns, because really it's a row column syntax here. Row I, all columns. I'm going to get the minimum of that row, and I'm going to do this for all rows. So min is going to be a list of all the minimums, because going back to the idea of the exercise, we're getting saddle points, which are going to be minimal in its row and maximum in its column. So we got to match them up. Get all the minimums, get all the maximums, and then match them up for equivalence. If there's equivalence between the two, we've got a minimum in its row and a maximum in its column. Good stuff. And I do a similar thing with the maxes. I use list comprehension. And here I'm going to be looping through column wise, like everything in the column. And I'm going to do my column slicing syntax. With this syntax here, you see it's kind of opposite of the one above. I'm getting the maximum of each column, where I'm getting, remember the syntax is row, comma, column. I'm getting everything in the row for column I. Everything in the row for column I. So I'm getting the max of that column. After this, I'm going to have my mins and my maxes, and I'm really just going to match them up, where I'm going to loop for each minimum. I'm going to see if I find a max match in a column, and if I do, then it's a saddle point. I'm looping through my minimums, and then for each minimum, I'm going to do a loop through all the maximums. Well, now range is. Talking and typing is not always easy. I'm looped through all the maximums, so yeah. So the outer loop, minimums, inner loop, maximums, rows and columns. And here I'm going to do a conditional that says if the current minimum that I'm on in that row equals one of the maxes, or I guess you could say the current max, then it's a saddle point. And actually I forgot something. I got to create my list of tuples to return, my saddle points. So on line 9, I'm creating the list of saddle points, of course empty right now. Back down to line 14, I'm going to now insert a saddle point. Oops, I was using different, like array list syntax from Java. No, I'm appending to a list. And the saddle point Like I said, it's going to be a tuple, so it'll be I, comma j. So I'm appending a tuple to the list. And again, if for each row minimum, I loop through all the column maximums, and if there is a match, it's a saddle point. And then I simply return my list of saddle points. Not saddle points. Saddle points. There is your code, my friends. And I think that is going to be it, unless there is a syntax issue somewhere. Let's run it through the paces. Yeah, that looks good. And that looks good. Ollie, ollie, oxen free. Impressive. Let's go. Way to start off 2026, my friends. All right, homies. We did it. Here is a saddle points, or saddle up, actually. Why is it called saddle up? It should be called saddle points. Here is saddle up. Python exercise done in Codewars and done on Dean Greer's YouTube channel. Awesome. So with that, y'all, I am out. Talk to you next time.